All right, let's talk about something that usually feels like just an overwhelming mountain of paperwork, but is actually your ultimate operational playbook. We are decoding the International Safety Management Code, or the ISM Code. Whether you're right in the middle of prepping for your MEO Class II competency exams, or you're already sweating it out down in the engine room, this explainer is designed to translate all that highly detailed maritime law into practical, everyday tools. We're going to strip away the heavy jargon and look at exactly how this framework keeps your ship afloat and your crew safe. Okay, let's map out our route for today. We've got 6 key areas. First, the origins and objectives of ISM. Second, the safety management system. Third, the chain of command and the DPA. Fourth, what ISM looks like down in the engine room. Fifth, audits, certificates, and PSC. And finally, number 6, some targeted MEO Class II exam prep.
So, Section 1, Origins and Objectives of ISM. To really get why the ISM code exists, you have to understand the historical stakes. It wasn't just invented in a vacuum by some bureaucrats. It was born out of absolute necessity.
Looking back at the timeline brilliantly illustrates exactly why we have this framework today. Back in the 1970s and 80s, the maritime industry experienced a massive, devastating surge in marine accidents. And when they investigated, the data consistently pointed to one major culprit. It wasn't the machinery failing, it was the management of the human element, human error. Because of those really tragic lessons, the IMO stepped in during the 90s, and by 1998, the ISM code became completely mandatory under SOLAS Chapter IX. The goal wasn't just to write more rules, right? It was to force a real culture of safe operation, pollution prevention, and continuous improvement.
Moving on to Section 2, the safety management system. That history brings us to the actual core mechanism of the ISM code. This is the engine that drives the whole thing. The official definition states that a safety management system, or SMS, is a structured and documented system enabling company personnel to implement the company's safety and environmental protection policy effectively. Now, if you're an engineer, please don't let the word documented trick you into thinking this is just office work. Out on your ship, the SMS translates directly to the real-world safety nets you literally rely on every single day. Your risk assessments, your emergency plans, your machinery maintenance procedures. The really crucial point here is that every single functional requirement you see listed has a physical, tangible counterpart on your vessel. Instructions and procedures, well, that's your permit to work system before you open up a pump. Emergency preparedness, that's the blackout drill you ran last Tuesday. Defined authority levels means knowing exactly who to call when things suddenly go wrong. It's a living, breathing system designed specifically to protect you.
Section 3, Chain of Command and DPA. Of course, any system is really only as good as the people running it. Let's look at the human architecture of the ISM code. If you are sitting for your MEO Class II oral exams, you have got to know this concept inside and out. The Designated Person Ashore, the DPA. This is the individual providing a direct link between the ship and top management. They're responsible for monitoring the safety and pollution prevention aspects of the ship. But honestly, most importantly for you in the engine room, the DPA is the person ensuring that adequate resources and shore-based support are actually provided. If you have a critical equipment failure and you need immediate spares, or you're managing an emergency response, the DPA is your direct lifeline to the highest levels of the company. Now, here is a classic Viva question. Examiners absolutely love to ask this to see if you truly grasp shipboard hierarchy under ISM. What exactly is the master's overriding authority? What's really fascinating about this rule is the sheer level of power and trust it places in the master. The master has the overriding authority and the responsibility to make decisions regarding safety and pollution prevention, which means if saving the ship, the crew, or the environment demands it, the master can literally deviate from the documented SMS procedures. They are allowed to break the standard rules to manage an unprecedented crisis. It is the ultimate safety valve built right into the code. Which brings us to Section 4, ISM in the engine room. Let's see how all this top-level theory builds directly into the daily life of a marine engineer officer. When you are doing your daily rounds, you are actively executing the ISM code. These everyday operations aren't just bureaucratic red tape. They are literally about operational survival. Lockout/tagout procedures, hot work permits, enclosed space entry protocols, strict bunkering checklists. These are all direct, hands-on manifestations of the SMS. When you faithfully follow a permit to work before isolating a system, you are utilizing the exact framework the IMO mandated to eliminate that fatal human error we talked about earlier. And here is how the system constantly improves itself. Imagine a junior engineer notices a slightly frayed lifting sling and submits a hazard report. That's step 1. Step 2, the management team conducts a root cause analysis and realizes, hey, a whole batch of slings from this supplier is defective. Step 3, corrective action is taken. Those slings are replaced immediately. Step 4, lessons learned. A fleet-wide alert is sent out and purchasing protocols get updated. So a single hazard report from one engine room just traveled all the way up the chain to create continuous fleet-wide improvement. That is the ISM code functioning perfectly. Section 5. Audits, Certificates, and PSC. But how does a ship actually prove to the outside world that it's following its own SMS? Well, that brings us to audits, certification, and port state control. Let's explicitly run the so what check here because examiners will definitely try to trip you up on the difference between these two certificates. The document of compliance, or DOC, is held by the company itself. It proves the company's overarching safety system meets ISM standards. But the safety management certificate, the SMC, is held by the ship. It proves that your specific vessel actually operates according to that approved SMS. It's a linked system. You simply can't have a valid SMC on the ship if the company doesn't have a valid DOC ashore. And getting those certificates, it requires a pretty rigorous audit cycle. First, the company conducts an internal audit to check up on their own ship. Then an external audit is performed by the flag state or a recognized organization, like a classification society. Only when both are totally satisfied with the objective evidence will the DOC and SMC be issued or endorsed. It's a constant, continuous loop of verification. Which brings us to the enforcers, port state control. PSC inspectors aggressively target ISM implementation. If they board your ship and find missing SMS manuals, or crew who are unfamiliar with their emergency duties, or really poor maintenance records in your planned maintenance system, they will act. If you have missing permit to work documentation for a hot work job you just did yesterday, that sloppy logbook can literally result in the entire vessel being detained. PSC wants hard proof that the SMS is alive and well on board, not just sitting on a dusty shelf. Section 6, MEO Class II Exam Prep. All right, let's aggressively transition into direct exam mode. The next few concepts are highly specific definitions that you absolutely must be able to recite and explain for your MEO Class II boards. First major definition. Non-conformity. Definitely memorize this. A non-conformity is an observed situation where objective evidence indicates the non-fulfillment of a specified requirement within the SMS. So, what does that mean practically? Well, if the SMS says the emergency fire pump must be tested weekly, and an auditor checks the logbook and sees it hasn't been tested in a month, that missing log entry is the objective evidence of a non-conformity. You simply didn't fulfill the specified requirement. Next up, the distinct difference between corrective action and preventive action. Trust me, examiners love to trip candidates up on this exact comparison. Corrective action is fixing the immediate problem. You have a leaky pipe, oil is on the deck, you clean up the oil spill. Problem solved for right now. Preventive action, though, is eliminating the root cause so it never happens again. You investigate, you find out the pipe joint vibrates too much, and you completely redesign the bracket supporting it. Corrective fixes the symptom, preventive cures the disease. Here is another incredibly frequent exam question that tests your practical, hands-on engine room knowledge. How do we define critical equipment under the ISM code? Critical equipment is defined as equipment or technical systems whose sudden operational failure may result in a hazardous situation. Because the stakes are so high, the ISM code mandates that these items require strict, specific measures in your planned maintenance system, or PMS. We are talking about the heavy hitters, your steering gear, emergency generator, fire pumps, lifeboats, and a main engine. When you get asked this in an exam, be ready to list these examples and clearly explain that they demand prioritized maintenance and regular testing because their failure directly threatens the entire ship. So as we wrap up this explainer, I want you to think about this critical question. If the ISM code relies on continuous improvement, how does your daily hazard report today prevent the maritime disaster of tomorrow? Remember that history we started with? The ISM code is not just a burden of paperwork. Every single checklist, every permit to work, every near-miss report you file is a brick in the wall protecting you, your crew, and the ocean. You are the operational edge of this code. By understanding this whole structure, from the IMO all the way down to the daily lockout/tagout tag on a purifier, you aren't just preparing to pass an exam, you're preparing to be a better, safer marine engineer officer. Keep exploring these concepts, keep reporting those hazards, and absolutely best of luck on your upcoming MEO Class II exams.